Welcome back, everybody. Problem set number 4 for Math 3A. Here's some examples. I'm going to do one that's similar to number 2, although number 2 has several parts, but here's one that's similar, then one that's like number 3, and one that's like number 4. So first of all, take the derivative and then find out the smallest positive value, so not 0, but bigger than 0, where the derivative equals 0. So usually I take the derivative and then I graph it to check my answer, but you can also switch the order, take a look at the graph first, and then do the actual work. So sine of x squared. So let me change the window, 0 to pi, that sounds like it might work, and then sine ranges between -1 and 1, so this looks fine. And then take a look at the graph, and right there, when it got to the top of that hill, that's the first time that the derivative equals 0. So if this is pi, this is about pi over 2. So this is, pi over 2 is 1.5 something. So this is maybe like 1.2 or so. Let's see. So first of all, take the derivative. And as I'm sure you know, the derivative of sine is cosine. And the chain rule says you can only do one derivative at a time. So there's the derivative of sine is cosine. Then the x squared just stays there. Now the chain rule says take the derivative of x squared, which is 2x. And now set it equal to 0. So it turns out that this 2x is not really going to give us a solution, because if you put this equal to 0, it's going to give us x equals 0, and 0 is not a positive number. So really I just need to put this part equal to 0. When does cosine of x squared equal 0? So then I just think of the cosine graph, which looks like this. So I'm just ignoring the x squared for a moment and just looking at the cosine graph. And the first time it equals 0 is right here. So this is 2 pi, in the middle would be pi, and then this is going to be pi over 2. And if this just said x, I would just say x equals pi over 2 and be done with it. But this does say x squared, so I need to say x squared equals pi over 2, and then solve for x by taking the square root. Usually when I do square root, I do put plus and minus, but this said keep it positive. So this point right here, when it got to the top of that hill, that maximum, that should be the square root of pi over 2. I'm just going to adjust the window so I could see that a little bit better. Go up to like 1.2 so I could see the top of that hill right there a little bit better. And then trace and put the square root of pi divided by 2. Yep, that is the maximum point, and the directions were just find the x value, so you don't need the actual x and y value on this one. Turns out x equals pi over 2 is it, and there we go. Then for the next one, find one value, so not necessarily positive. So this is like number 3 on the second page of the problem set, where the second derivative equals 0. So find the derivative and then find the derivative of the derivative. So for this, I get to use the product rule. So take the derivative of x squared, which is 2x, and then leave the e function alone, plus now leave the x squared alone and take the derivative of the e function, which is the e function. And then the chain rule says you also need to take the derivative of negative x, which is a -1. And now I need to find the second derivative. Now, if I leave it the way that it is, I'm going to have to use the product rule right here, which is going to give me something that looks about like this. I'm also going to have to use the product rule right here, which is going to give me another thing that looks like this, and it might go off the page. So what I'm going to do is, before taking the second derivative, I'm just going to factor out this e function. You don't have to do it. It just makes the work a little bit simpler after this. So if you factor out the e function right here, it's going to leave behind a 2x. And once these two are put together, it leaves behind negative x squared. And I know that you're saying, why didn't you also factor out an x? You could do that. Well, if I was solving for x, I definitely would. But I want it to be this way so that this is just a product of two things, the e function and then this polynomial. So when I go to do the derivative of the derivative, I only have to use the product rule once. So take the derivative of the e function, which is the e function, and then take the derivative of this negative x, which is a negative 1, and I'm going to put that negative 1 right here. And then just copy down what's in the parentheses. So there's half of the product rule. The other half goes, now leave the e function alone and take the derivative of what's in the parentheses. So the derivative here would be 2, and then this would be minus 2x. So there's a 2 minus a 2x. And I forgot to write down that's double prime. Now set that equal to 0, and then factor. So this has the e function, and this has the e function, so I'm going to factor out that e function. And then this negative could be distributed, so it's actually going to be negative, negative, which makes it a positive x squared. And then negative times 2x. And then for this one, I factored out this e function, so all that's left is this. So there's another negative 2x that's left, and plus a 2. And then where is that equal to 0? Well, the e function itself never equals 0, so I just need to know when this equals 0. So that means I've got x squared minus 4x plus 2. When does that equal 0? And you're right, we need to use the quadratic formula. So that's going to go negative b plus or minus the square root. The b gets squared minus 4 times a times c, all divided by 2 times a. And since the a is a 1, that's just a 2 right there. And how much is inside the square root? So this is going to be 16, and then this is going to say minus 8. And 16 minus 8 is 8. So you get x equals a 4 plus or minus the square root of 8 divided by 2. And I would prefer to get the decimal answers. So using a calculator, we've got a 4 plus a square root of 8, and then that whole thing is divided by 2. Oh my gosh, that almost looks like pi. And then do the same thing with subtracting. So we get x equals 3.414, and then x equals 0.586. Oh, the directions said find one value, so as you could see, I'm an overachiever. I got twice as many. And then let me see if that makes sense. So if I graph the original problem, that's going to be the x squared times the e to the negative x. And let me just go zoom standard and see if I can see it. Okay, so I don't need any of this negative down here, so I'll change this to not have any negatives. And then you could see that it drops down, it bumps off of the x-axis. And then what's happening at, I think I need to change my window a little more because I need to be closer to these values. So maybe from -1 until 6, and then -1 until 6. Okay, so what's happening here and here? So right here is where the derivative equals 0, and right here is where the derivative equals 0. But that's for the first derivative. What we found is for the second derivative. And second derivative is where it changes from concave up to concave down. So if you look at the graph, this part, so until right about there, that's concave up. And then this part is concave down, and then it's going to change back to concave up. So you don't really need that for this problem, but we do concave up and concave down throughout the rest of the semester, so I might as well just show it real quick. So when I plug in the trace point 586, so that's this point, the point 586, and then it's going to be concave down until we get to the 3.414. So that's right here, 3.414. And then it's concave up after that. So I'm just exaggerating to make it look. So this is concave up, this is concave down, and then this is concave up. All right, then to the last one, which is like the last page of problem set number 4. We've got this function going from 0 to 2 pi, and that's not the right page. This is the right page. So for number 4, we've got this function from 0 to 2 pi. Write down what's the derivative, set it equal to 0, and then solve for x. And then you could use a graphing calculator, although you should use the x and y to find out where the 2 minimum points are. So that's what we're doing right here. First of all, the derivative. So the derivative of 1/2 x will just be 1/2. The derivative of cosine is negative sine. And then I need to do the chain rule. The derivative of 2x is 2. So that's part A, find the derivative. Part B, set the derivative equal to 0. And then solve for x between 0 and 2 pi. So I could take this negative sine function and move it to this side. So that means it's going to become positive 2 sine of 2x equals 1/2. And then I could eliminate this 2 by dividing both sides by 2. So that means that this is going to become 1/4. So when does sine of 2x equal 1/4? Now this actually has an infinite number of solutions. I need to find out how many solutions are there between 0 and 2 pi. So for that, I'm going to take a look at the graph of the original function. So y equals 1/2 x plus cosine of 2x. Change the window to go from 0 to 2 pi. And then, so this would actually be going up. By the time you get to 2 pi, this is going to be pi. And then this could be as much as 1. So that would be like 3 plus 1. I'm just going to go -5 to 5. And hopefully I can see the whole graph. So the derivative will equal 0 down here at this minimum. That's one answer. 2 answers. 3 answers. And perhaps there's a 4th one right there. Perhaps there's one right there. So we're definitely looking for 1, 2, 3 answers. There might also be one right here. There might also be one right there. So this is basically saying if you look at the sine function and ignore the 2x for a moment. So the sine function looks like this. And then when does that equal? 1/4. So if you make a line go straight across, there's going to be 2 answers. To get this first answer, you just do sine inverse of 1/4. So what is, now I've got ink on there. Hold on, that's bugging me. Okay, what is sine inverse of 1/4? And then this is going to be this first answer right here, 0.253. And then this second one, the calculator is not going to give me. I have to say, well, if right here, where it crosses the x-axis is pi, then this is just to the left of pi. So that'll be at pi minus 0.253. So this gives me two solutions. When this has a 2 in front of it, that means we're actually looking for 4 solutions. If this had a 5 in front of it, we would have 5 times 2, we'd be looking for 10 solutions. So because this has a 2, we're looking for 4 solutions. So if you look at the sine graph and you continue this line across, then there's going to be 2 more solutions. All right, so one solution I got was 2x equals that first one, 0.253. The second solution I got is 2x equals this one, which is pi minus 0.253. So that's a 2.889. Now I need to find the third solution, which is over here. Well, because the period of sine is 2 pi, that means if you want to get from the first answer to the third answer, you just have to add 2 pi. So I just need to add 2 pi to this one. So another one is 2x equals 0.253 plus 2 pi. And then to get from the second answer to the fourth answer, you also add 2 pi. So then for this one, I just need to add another 2 pi. So 2.889 plus another 2 pi. So a 0.253 plus 2 pi. And then I also need 2.889 plus 2 pi. So this one is 6.536 and this one is 9.172. Okay, notice that all of those say 2x equals. So whenever you're looking for multiple answers, you find all of the answers, in this case 4 of them, leaving the 2x until the very last step. Now divide each and every one of these by 2. So here are my 4 answers. So divide by 2, 0.253, divide that by 2, so 0.127, and then take this one and divide by 2, a 1.445, divide this one by 2, 3.268, and finally 9.172, divide that by 2. So 4.586. That's this part. And then where are the 2 minimum points? Write that down as a point, x and y. So if you go back to the graph, then there's a minimum point right here and right here. So I believe that this is the 0.127, trace 0.127. So that is where it had a maximum value, then a minimum. So for the minimum values, let me make sure I get that on the screen. That's going to be this one. So that's going to be the first one, the second one. That's the third one and the fourth one. So it should be these 2 with the check marks. So 1.445, and then write that down as a point, 1.445, comma, negative 0.246. And then this should be the next one. So the 0.4586 should be that point. 4.586. Yes, that looks good. So the other minimum, 4.586, comma 1.325. All right, we've now done part A, B, and C. Next, it says find the second derivative. So now, go back to where you have the first derivative, and now find the second derivative. So the good news is the derivative of 1/2 will be 0. That negative will stay there. The derivative of sine is cosine. The 2 will stay there. And then the chain rule says now take the derivative of 2x and multiply by that. And if you set this equal to 0, well, this is a 4, so I could just move that to the front. And then you could even get rid of this -4 by dividing both sides by -4. And then all that's left is, it says, when does cosine of 2x equal 0? So if you look at the cosine graph, ignoring the 2x for a moment, here's the cosine graph, and where it equals 0 is at pi over 2 and 3 pi over 2. And because this says 2x, we actually need twice as many answers, so we need 2 more. So this one is 1 pi over 2. This one is 3 pi over 2. The next one would be 5 pi over 2, so it uses the odd numbers, and then 7 pi over 2. And now for each one of those, it's going to say 2x equals. So 2x equals the pi over 2, 2x equals the 3 pi over 2, etc. And once you write down these 4, then the last thing to do is divide each and every one of them by 2. Or multiply by 1/2. So when you do, so if you multiply by 1/2 and multiply by 1/2, then it's going to say x equals pi over 4. And you could say x equals each time, or you could just put a comma in between. The next one would be 3 pi over 4. And this one would become 5 pi over 4. And the last one would be 7 pi over 4. And then the last question is saying, when is it concave down? So if you go back to the graph and you try the pi over 4, so pi divided by 4, then that part to the left is concave down. So for concave down, that's going to go from 0 to pi over 4. Then if I try the next one, 3 pi divided by 4, then between these two, that's concave up. So I need a pen that's not leaking. So then this part is concave down, so that should be from 3 pi over 4 to 5 pi over 4. So this is the 3 pi over 4. Right over here should be the 5 pi over 4. So then from 3 pi over 4 to 5 pi over 4, it's concave down. So this part is concave down. Then this part is concave up, and then this last part is concave down. So then that would be from 7 pi over 4 to 2 pi.